Hello students, let's continue the session on decimals. In the previous session, we have learned the definition of a decimal and the types of decimals, that is terminating decimal and non-terminating decimal. Let us begin the session with representation of decimal on a number line. How to represent the decimal on a number line? We know how to represent the whole numbers on the number line, and also we have learned representation of integers. Let us consider the image shown below. Here the digits 0 and 1 are represented on the number line. If we divide the number line into two equal parts, as shown in the figure in the below, what do we get in the middle value? It will be 0.5 because the distance from 0 to 1 is 1. On dividing by 2, we get the value as 0.5. This point is at 0.5 units away from 0. In order to represent decimals on the number line, we divide the section between two whole numbers as per the places after the decimal present in the number to be represented. Suppose if I consider a number line, here the numbers 0, 1, 2, 3, these are whole numbers. When I divide the distance between 0 to 1, 1 to 2, 2 to 3 into 10 equal parts, the sixth part starting from 0 will represent 0.6. The second point after 1 before 2 represents 1.2. Suppose if you want to represent 2.5, you need to count 5 after 2 before 3. This particular point will represent 2.5. This is how we represent a decimal number on the number line. Here I have shown when the decimal is only 1. If the decimal part is only 1, this is how we represent on the number line. You may get a doubt now, what if the number is 1.25? How do we represent this on the number line? This particular concept you are going to learn in class 9th. We are not going to represent it, we are going to visualize it. You will get a question that visualize 1.25 on the number line. As I said, 1.25 is a number after 1 before 2. Suppose if I want to visualize it, I have to consider a number line. I'll show 1 and 2 on the number line so that you can represent 1.2. If I divide this into 10 equal parts, if 10 parts are there, the second part is going to be 1.2. The next part is going to be 1.3. Now if you magnify this length 1.2 and 1.3, if you magnify it, between 1.2 and 1.3, if you make 10 equal parts, again I am making 10 equal parts, the fifth part will indicate 1.25. This is the fifth part. This is how we visualize a decimal number on the number line, which you are going to learn in detail in class 9th. Now let us take up a concept called as like and unlike decimals. Decimals having the same number of decimal places, they are called as like decimals. Once again, decimals having the same number of decimal places are called as like decimals. That is, the decimals having the same number of digits on the right of the decimal point are known as like decimals. Otherwise, the decimals not having the same number of digits, they are called as unlike decimals. Let me give some examples. Look at 5.45, 17.04, 272.89. These are all like decimals. The reason is they are having two numbers, two digits after the decimal point. So the same number of decimal places are there. So they are called as like decimals. Look at 7.5, 23.16, 31.054. Here the number of decimal places after the decimal point are not the same. 7.5 is having one decimal place. 23.16 is having two decimal places. 31.054 has three decimal places. These are unlike decimals. Note that if we put any number of annexing zeros on the right side of the extreme right digit, the decimal part of a number does not alter the value of the number. So, unlike decimals can always be converted into like decimals by annexing required number of zeros on the right side of the extreme digit. In the decimal part, I'll make it clear with the example. 9.3, 17.45, 38.105, they are unlike decimals because the number of decimal places are different. They can be now written as 9.300, 17.450, 38.105. Now they are having the same number of decimal places, so they can be converted as a like decimal. Remember friends, if there is a number 2.5, it is same as 2.50, that is same as 2.500, that is same as 5 followed by any number of zeros. They are all the same. So at any point of time we can convert a unlike decimals into a like decimals by annexing zeros after the extreme right decimal part. That is what is explained here. 0.1 is same as 0.10, same as 0.100, etc. Same way, 0.5 is 0.50, 0.500, etc. and so on. That is, by annexing the zeros on the right side of the extreme right digit of a decimal part of a number doesn't alter the value of the number. Now let us study the conversion of unlike decimals to like decimals. In the conversion of unlike decimals to like decimals, we follow these steps. First, the decimal number having the maximum number of decimal places, say n, that we are going to identify. Now we'll convert each decimal number to n places of the decimals. Here you need to note, if we put the number of zeros to the right extreme of decimal, the value of the decimal remains the same. 0.8 is same as 0.80, which is same as 0.800. In other words, 0.8 is 8 by 10. It is same as 80 by 100. It is also same as 800 by 1000. When we convert and simplify, we get 8 by 10 itself. Thus, to convert unlike decimals to like decimals, we follow this method. First example, convert the decimal numbers 5.42, 11.6, 212.075 into like decimals. Here we observe that the given decimals are having the maximum number of decimal places as 3. That is there in 212.075. The decimal 212.075 has got the maximum number of decimal places, that is 3. Now we convert each of the decimal numbers into the one having the 3 decimal places. Say 5.42 is written as 5.420. I have added a 0 here. 11.6 is same as 11.600. 212.075 is already having 3 decimal places. Therefore, all the numbers, they are becoming like decimals. Let's see one more example. Convert the following unlike decimals into like decimals. Here count the number of decimal places. The maximum is 3 again. Now observe 26.361 is having a maximum decimal places, that is 3. So we convert other decimal places into the one having 3 decimal places. 1.72 is written as 1.720. 26.361 is already having 3 decimal places. 3.35 is written as 3.350. 0.9 is written as 0.900. Therefore, all these numbers, they have converted as like decimals. Let's see one more example. Are the following decimals like or unlike decimals? If the decimals are unlike, then convert it into like decimals. Here the decimal places are unlike because the number of decimal places are not the same. Here the maximum number of decimal places is 4. That is there in 20.0254. Now 9.5 can be written as 9.5000. 18.235 is written as 18.2350. 20.0254 is already having 4 decimal places. Thus we have converted them into like decimals. Now I have made it very clear how to convert a unlike decimals into like decimals. Let us now learn a concept of converting a decimal into a fraction. In converting decimal into a fraction, we follow a few steps. The first step is to obtain the decimal. The second step is remove the decimal points from the given decimal and take as the numerator. The third step is at the same time write the denominator as many zeros to the right of 1. For example, 1 0, 1 0 0, 1 followed by 3 zeros, etc. As there are the number of digits in the decimal part, and then simplify it. We can express a decimal number as a fraction by keeping the given number as a numerator without a decimal point and writing 1 in the denominator followed by the number of zeros which are equal to the number of decimal places of the given decimal number. So for example, 124.6 is nothing but 1246 divided by 10. Here there is one decimal place, therefore the denominator is having 1 followed by 0. 1 0 is there. Here in this there are 2 decimal places, hence there are 2 zeros considered along with the 1. Here there are 3 decimal places, so 1 is followed by 3 zeros. Here observe the numerator. The numerator is the given number without the decimal in that. The problems will help to understand how to convert decimal into a fraction. Say for example, in 0.7 we will change the decimal to fraction. First we will write the decimal without the decimal point to the numerator. Now we write the denominator 1 followed by 1 0, as there is only one decimal place here. So 0.7 is nothing but 7 divided by 1 followed by 1 0. Here how many decimal places are there? The same is written, same number of zeros are taken in the denominator along with 1. Therefore we observe that 0.7 is converted as 7 by 10, which is a fraction. Let's convert 3.91 into fraction. Write the given decimal without the decimal point as a numerator. In the denominator 1 is followed by the 2 zeros because there are 2 decimal points in the decimal number. Here there are 2 decimal points, so 1 is followed by 2 zeros. So 391 upon 100 is the fraction, which is same as 3.91. 2.017 is 2.017 divided by 1. Now to convert, we can multiply with 1000 because we are having 3 decimal places. So 1 is followed by 3 zeros. It can be expressed in a direct way also, or else you can follow this method. The numerator is multiplied with 1000 and the denominator is also multiplied with 1000. We get 2017 upon 1000. This will be same as 2.017. Let's see one more example. Convert 0.0035 into fraction in the simplest form. Look at this. Here there are 4 decimal places, so 4 zeros are taken along with the 1 and multiplied to both numerator and the denominator, we get 35 divided by 10,000. They have asked to express in a simplest form both the numerator and the denominator are divisible by 5. Hence we get the result as 7 upon 2000. Seven upon 2000 is the simplest form of 0.0035. Let's see one more example. Express the following into fractions and write them in a simplest form, of the lowest form. For the first one, we can divide 5 by 100 because there are 2 decimal places here. So 5 by 100, both the numerator and the denominator are divisible by 5. So to reduce, they are divided by 5 in the both numerator and the denominator. Probably this look you may understand better. They are divisible by 5, hence we get the result as 1 upon 20. 1 upon 20 is the lowest form. 3.75, the same procedure is followed. 1 is followed by 2 zeros, and 375 upon 100 is a fraction representing 3.75. To reduce, both the numerator and the denominators are divided by 25, that is 375 divided by 25, then 100 divided by 25. On division, we get the simplest form as 15 upon 4. Now exactly the reverse part we are going to learn. How do we convert a fraction into decimal? To convert fraction into decimal, we know that decimals are the fraction without denominators, 10, 100, 1000, etc. In order to convert the fraction into decimal, we do follow steps. Step 1 is to convert the given fraction into equivalent fraction with the denominator 10 or 100 or 1000. If it is not so, second step is to take the given fractions numerator, then mark the decimal point after one place or 2 places or 3 places from right towards the left in the given fractions denominators is 10, 100, 1000 respectively. Note that you need to insert the number of zeros at the left of the numerator if the numerator has a smaller number of digits than the denominator. To convert the given fraction having 10 in the denominator, we will just place a decimal point one place left of the first digit in the numerator. 6 by 10 is 0.6. Here you can observe 6 is the only digit, so 0.6 is written. In the next example, 1.6 is obtained by placing decimal point after one digit. Now you will understand, if the denominator is 100, we take 2 decimal places. Here there won't be any doubt. Here there are only 2 digits, so 0 point is considered. Here there is only 1 digit, so 0 is taken along with the 7. That is what the last sentence was. This was the last sentence. Note, insert the number of zeros to the left of the numerator if the numerator has fewer digits than the denominator. Here one more will take if the denominator is 1000, here the 3 places from the left we have to place the decimal point. So 9 is the only digit. To make it as 3 places, 2 more zeros are included along with the 9 after the decimal point. Here 99, so 0, 1 0 is taken, so that there are 3 decimal places. Here in each case there is 3 decimal place. That's all for today's session. We shall continue some more concepts in the next session. Thank you.